You guys, that's gonna be the drill on Tuesdays. Tuesdays we start off tutorialing out. So guys, this is where we left off yesterday. I mean, this is where we left off last tutorial. So for this tutorial, I'm planning on getting this little guy to move. We'll see about jumping. I have my own character, so I'm not gonna be drawing him. So this is what he looks like in A Sprite. He's a little cute mushroom man. So if I press C, it'll tell me the, C in A Sprite tells me the dimension, so it's 20 by 20. Since our tile set is 16 by 16, you need to take into account that. So we'll just minimize that and let's go into our character scene. Go to the sprite property and put our mushroom in there. So you might wonder why we're using this capsule shape, and it has to do with the friction. If you use a square, there's more points of friction, and sometimes your character can get stuck, and you'll be like, and you won't. It's not so obvious why it's getting stuck, but when you're using this shape, there's only one point that it's touching on the ground, and it's a much smoother, better experience. That's good. That's good enough for me. Okay, so let's run it, make sure everything is good. Penisel, thanks so much for the follow. Okay, so now we want this dude to move using our arrow keys. Oh! So we're gonna have to go into his script. But first, you need to decide what, how you want him to move. You could either use like the arrow keys, or I really like using WASD. So we're gonna go and add that. So you need to go up here to your project settings, and you start off on general. You're gonna want to go to input map, and if you look here, these are all inputs. And you see you could use different controllers, like an Xbox controller, Nintendo, but we're just gonna focus on the arrow keys. We wanna make our own custom inputs. So for left, we're gonna add the action here, click add. We'll do right, and I clicked enter, so I didn't have to click this add. And then we'll do jump. Bam. So now that we have these custom inputs, we need to tell it what we want. So we're gonna go here to a key because we're using the keyboard. If you have like a Joy Axis, I've never actually used these, but I assume it's for different joysticks for controllers. I don't know. So we're gonna go here to key, and for left, I want to use A. I'll also add the left arrow for people who prefer arrow keys. Cool, so now left is A, or the left arrow key, right is D, or the right arrow key, and jump is spacebar. So now we're gonna put these inputs in the physics process. We did this last time to show you how fast the physics process loops. So we need that speed because we want to be constantly checking if the user is putting the inputs. We're going to test it. So we're going to say if input is action just pressed, and we have our custom ones here. So let's test left out. Okay. So let's go to level 1. I'm going to click A, and you see that every time I click A, it says we're moving left. So let's do an L. And we'll also do... So now we'll just... Yeah, it's else if. I think it's the same in Python. Okay, test out each one. Left, right, jump. So they're all working. I could also use the arrow keys. Everything is working. Perfect. There's a difference between is action just pressed and is action pressed. So this it'll check each frame and it'll do it multiple times. So like, you see, like I pressed it once and it like printed it 1, 2, 3, 4, 5, 6, 7, 8 times. Actually, for the tutorials, no music. Tutorials, no music. So yeah, that's important to know. The difference is action pressed, which it checks each time, or as opposed to is action pressed, it just checks if it was pressed once. Okay, so now that we know this is working, that's super pog. Now we need to learn about a special type of data type, and it is the vector. Dun dun dun, because we're gonna need to get the velocity of our character. And I know velocity sounds very scary if you're not into programming or physics or any of that, but it's gonna be okay. So let's make a variable called velocity. And yeah, for now we'll leave it like this, but this is gonna be a vector 2. So let's open this up. So a vector 2, all it is it's an x and a y. So in Godot we write it like this, vector 2. This velocity would be if the character is standing still. So let's say this is our character. Okay. If our character is moving to the right, let's think of it, you know, let's go back to elementary math. I don't know if this is elementary math, but we have an x and a y coordinate. So we all know when we have this coordinate system, this is like negative value, negative, this is positive, positive, nice. Well, in Godot, we just need to do a flipperoonie. This negative is gonna come up here and this positive is gonna be here, but the x is gonna be the same, woo. Alrighty, so if our dude, what this means is if our dude, okay, if it stops, our velocity is 0, 0. I'm not following myself, ill. So if it stops, our velocity is 0, 0. But if we're traveling in the positive x direction, this, it depends how fast we're going, but let's say it's 1. This will be a 1, and we'll put it inside of a function in our character. And if this is 1, it just means that we're going in the right direction. If we go in the left direction, I hope this makes sense to all of you beautiful people. If we go in the left direction, this is just gonna turn negative. And like I said, it's flipped. So if we're going up, it's gonna be 0, -1. And if we're going down, it's 0, +1. Yes, so that's why we need this vector 2. And I will show you how to write it. So our velocity, we're gonna start off, yeah, diagonal would be 1, 1. Thank you for that, Knut. So this is how you write it. 0, 0. So there's actually 2 ways. So this is 0 movement. There's 2 ways we could write this. We could either write it like this, or we could do it like this, .0. Oops. Just to avoid confusion, I am going to do it like that. But those are the 2 different ways. If you want to add a data type, you could just do vector 2, and that is the data type. So if we make it, if we say 1, it's gonna shoot us an error because it's expecting a vector 2. Nice. Alrighty, so now we have this velocity. Great. Before we do the movement, we're gonna have to implement gravity ourselves. By the way, guys, everything that we're doing now in Godot 4.0, when you make a character node, it already comes with all the movement script. I just want to throw that out there again because I think that is so awesome. Cool, so we're gonna need another variable for gravity, but actually it's not gonna be a variable, it's gonna be a constant. So this is the first time we're using this. It's the const keyword, and I will show you in a jiffy the difference. Normally it's good to make constant variables all capital. That's just what I learned. And our gravity is gonna be 800. This is gonna be the force pushing our character down. And if you remember from here, in order to push us down, it's positive y. Cool. So what a const is it's a variable that you can't change. I don't know, I guess it's not called a variable because variable changes. So it's a value, yeah, value that does not change. So here on the ready function, I can make the velocity equal to vector2, 1, 0. That's fine. Godot doesn't mind that. But if I try to change our gravity value, that's when it's not allowed, because can't assign a new value to a constant. So yeah, you can't change the value of a constant. When you use this keyword, it's unchangeable. We have this velocity variable, and it's gonna help us move our character. Let's go into our character, and we're gonna right click the character, and we're gonna go to open documentation. And this is a documentation for our kinematic body 2D. And remember, in our script, we're extending this kinematic body 2D, which means that we get access to special methods and properties, and we're going to use one of those functions. So you can read up on all of this, but we're going to need a special method in here, and it is called move and slide. So this is the function that's in charge of moving our character, and it is very pog. Yeah, okay. So at the end, we are going to, one second. We're gonna say velocity equals move and slide. And then we're gonna put our velocity in here. Cool. So I'm gonna just put pass. So yeah, let's test it out. Okay, nothing is happening. That's what is expected. But what happens if we change our vector2 here to, let's say, we'll put a 1 here. Let's see what happens. You can see actually the character is moving slightly to the right. Let's make it a little more drastic. Yes. So now our character is moving more to the right. And that is because this velocity is in the move and slide function. Actually, can I do it without that? Yeah, you could do it without that. But I like to make it equal to. So all we're doing is we're putting our velocity, this vector2, into this move and slide function, and this move, since it's a kinematic body 2D, it's causing our character to move. Nice. So what we need to do now, Robson, thanks so much for the follow, is we need to apply gravity to our character. We still want this to be 0, but we want our character to go down because it's kind of floating, and we want it to be a little more realistic. And because if you remember, when we use a rigid body, the gravity is like applied. There's like a check you could click and it applies gravity. Kinematic body, you need to program the physics yourself, but it has a little bit of physics, so it makes it a bit easier. So ways that you can, with vector2 variables, if I want to change the y value, I could just come here, because we want to change this, look here. Remember, positive y goes down. So we want a positive y here. Let me show you. You see, we want our character to be pushed down, and since the floor has a collider on it, it'll act kind of like gravity. So we want to add to the y value. So in order to do that, we're going to do velocity y, so we could change this y value, and we're going to add our gravity. So our gravity is 800, so that's like a big force, but that's what we're going to do. And now our character, even though here it starts off the ground. The gravity is pushing it down. So we're almost done here, kind of, not really. One thing you need to do to make it consistent, because everybody has like different PCs and stuff, is we need to multiply it by delta. This is a variable that comes with this physics process. I don't really understand it so much. I just know that it's better when you don't have any questions. Like that. Yeah. Yes. It smooths it out, smoothing it. Okay, so now that we know that how to go to the right and the left, if our character clicks the left key, we're basically, what we want to do is we want to change the X, and we know that in order to go to the left, we need to subtract. So minus equal 1. But we're going to create a variable called speed, because 1 is a bit too slow, and we'll try out 10, so we will put here speed. And the other direction would be velocity x plus equal speed. Alrighty, let's test it out. Let's test it out. Woo! Woo! Okay, that's way too slow. So let's try 100. Whee! Oh yeah, oh yeah, oh Jesus. But if you let go, it like slides. So yeah, that's a problem. We don't want it to just go on forever, hot mama. So that's why we'll have an else here. Velocity. So if we click left, we want to add the speed like that. If we click right, we want to add the speed like that. If we let go of everything, we want the velocity x to equal 0. So he can't slide off. I think let's try is action pressed. So if we're holding it down, it'll apply it more. I think that's what. Oh, jeez. Okay, yeah, we need a lower. Let's lower that just a little bit. Just a smidge. Just a little smidge. Oh yeah. Oh yeah. Look at that. It doesn't feel the best, but you know, we're making our first game. Alrighty, now let's do jump. We're gonna have another variable called jump force. And here, yeah. It can also be a const. Jump force. And we're gonna make it negative, because remember, back to this graph. If you want to go up, it's negative y. So we'll do here, we're going to change the velocity y to the jump force. And we're not adding it, we're just going to make it the jump force, because it's going to be a force. Cool, but actually there's going to be something else we're going to do. We're going to need to do because of this. Oh, actually it works right off the bat. But normally there was a problem with jumping, and you would have to add here vector to up. I don't know, maybe in 3.5 they changed it because it doesn't know what up was. Okay, let's go into this function and see. Up direction. Yeah, sometimes when you add jumping, this is just, let's print it out. You guys can see what it actually is. See, it's -1, 0, -1. That's the up direction. Cool. So let's see if we could jump onto this lovely platform. Woo! Woo! Yeah! You're gonna have to get used to it a little, you know? We have to start somewhere. You're gonna add a speed limit if you're adding velocity. Yeah, of course, this is not the best way to do the code. It is nowhere near the best way to do it. This is just when you're learning how to program. It's the easiest one to conceptualize. So I wanna explain this if, elif. Alrighty, so the way that this works is if the person is clicking left, it's gonna run this code. If they're not clicking left, they're gonna go to the next line and run this code. Oh, no, they're gonna go to the next line and check and the computer's gonna say, okay, they're not clicking left, but are they clicking right? And if we're clicking right, then it'll run this code. If both of these are not being done, then it automatically does this. So that's what we want. We either want to go left, right, or if we're completely off, our fingers are off the keyboard, then we'll do this. So yeah, like I said, this is not the most efficient way to do it, and you could tell that it's not the most efficient way because it feels kind of weird. And look, like our mushroom stops, like, you know, because we're letting go, it like stops midair, and it doesn't feel if you press both right and left, it's gonna go left because this will be true, so it won't even run this. That's the way. Because miraculous, it's a good question. This won't even be read because it'll say, okay, this is true, cool, run this, and don't do these because these are only run if this is false. Oh yeah, so nice. So the reason why Y is like that is because back in the day, the way the screens worked and were drawn is that they would start here. So if you went to the right, you'd be adding to the X, but if you were going down, you were adding to the Y. Mood today. What if you remove L from Elif, right, so it goes. Okay, let's do that. So if it'll check, I think, okay, let's think of it conceptually because it'll be the same except for when you're clicking both of them at the same time, because if you remember when we had this and I clicked both of them at the same time, it would just do left because it wouldn't have time, it wouldn't even read this. So if I take this off, I think it'll cancel each other out and we'll stay in one place if we're pressing them at the same time because it'll run both of them. And if we're subtracting velocity x by speed and we're adding velocity x plus speed, it'll cancel it out. So let's do it. I'm gonna hit left and right at the same time. I think the reason it's able to go right is because I clicked right first. And it's adding it a little bit faster. But if I really click it at the same time, yeah, see, I clicked it at the same time, so it stopped. But if you click one even a second before the other, because our normal speed is like this. Oh wait, it's not even going left at all. Oh yeah, because this is else. Oh, yeah, that's true. That is true. What's happening, it can't do this because if we're not clicking right, it's gonna do this every time. So if we're just clicking left, yeah, so that's true. But if I comment this out, I can go left and right, but if I click both of them at the same time, it interferes with it. Okay, alrighty guys, I only want these tutorials to take up like 30 minutes of the stream. I want them to be consistent, so let's put it back. That's the code for today. We can get rid of that. We're not using it. If we need to set things up, we might use it, but yeah. Cool, we have a little bit more life in our game now.